When we started activity 1.3, we started talking about this spinner. We did number 1, where we counted all the sections to get our total number of outcomes. We listed out the sample space. Now, one mistake that I'm seeing a lot of students make is that because we used a number cube on activity 1 and 2, there is a misconception that sample space is always 1, 2, 3, 4, 5, 6. Why is this sample space not 1, 2, 3, 4, 5, 6?
Because it has letters.
Because this spinner, you are correct, doesn't have 1 through 6. It has some letters on there as well. So, 1, X, 3, 2, Z, and 5 was our sample space for this spinner. Then we moved on and we did number 3 together. Finding the probability of spinning a letter. A, we listed out the sample space and circled the letters X and Z. B, we wrote the probability, 2 letters out of 6 total sections, 2/6. On C, we described the complement as the probability of not getting a letter. Again, listed out our sample space. We do not want a letter, so we crossed out the 2 letters and circled what was left over, 1, 3, 2, and 5. So the probability of not letter was 4/6. 4 out of 6. Number 4, whose book are we using for number 4?
It says describe the event and possible outcomes of the event, and it's saying an odd number. So 1, 3, and 5 are odd numbers, so you circle it. And then it says calculate P odd number. So you put P odd number, and it would be 3 out of 6 because there's 3 odd numbers and there's 6 outcomes. And then it says describe the complement of this event and possible outcomes and the complement.
So what would the complement be?
It would be X, 2, and Z. And then it says calculate P, not an odd number. And X and Z are not even numbers, so it's not an odd number. So that would be 3 out of 6.
Thank you. So you got it. So we listed out the sample space, circled the odd numbers, 1, 3, and 5. B, calculate the probability of an odd number, 3 odd numbers out of 6 possible outcomes, 3/6. C, describe the complement, which was this right here, the probability of not an odd number. So that would be not 1, not 3, and not 5, which left X, 2, and Z. X and Z are not even numbers, so they're for sure not odd. So on D, the probability of not odd is 3/6. And we can also check it because the sum of the probability plus the complement will always equal 1. So 3/6 plus 3/6 is 1 whole. Okay, here's number 5. Oh, there we go. It does fit zoomed in. So number 5 said determine the probability of getting a vowel. List out our sample space. None of these are vowels. What is a vowel? A, E, I, O, and U. There's no A's, E's, I's, O's, or U's. So that was 0 out of 6. C, describe the complement of the event, probability of not vowel. When we list out the sample space, there's nothing to cross out because there are no vowels. So the probability of not a vowel was 6 out of 6. None of them are vowels. So all of them are not vowels. And we know we're correct because the probability plus the complement is one whole. So, great job. Thank you very much. Let's go on to the next page. Real quick, before we talk about activity 1.4, there is something that you need to know about spinners. Spinners have to be fair spinners before you can find the probability of them. What I mean by that is that all the sections on the spinner have to be the same size. So if we look at this spinner, the spinner square game is a game at the kids zone. The game consists of spinning the square spinner. If a player takes a spin and the spinner lands on B, the player wins a prize. If the spinner lands on A, the player does not win a prize. So in order to win, the player has to spin the letter B, this section right here. You can go ahead and shade that in. You can just shade it in with your pencil. 6 is asking us to find the probability of each section. But before we can do that, we have to adjust our spinner so that the sections are the same size. So to do that, we can cut our spinner in half. Our sections are still not the same. We can cut it in half again. We still don't have the same because this little piece is smaller than this little piece. So we're going to draw the diagonal. But still, I've got this big square and this little triangle. So still our pieces are not the same size. So I can draw this diagonal. All I'm doing is drawing lines on the spinner, trying to make all the pieces the same size. All the sections the same size. How many sections are now on the spinner? 8. 1, 2, 3, 4, 5, 6, 7, 8. So we now have 8 total. How many of these sections are not shaded? 5. So there are 5 sections labeled A. How many sections are shaded? 3. So there are 3 sections labeled B. Now that we have this information, what is A? The probability of getting an A on the spinner.
5 out of 8.
5 out of 8. Because there's 5 sections that we didn't color in, so 5 8 out of 8 total. What about B? 3 8s. Because there's 3 sections that we colored in out of 8 total. If you were to spin the spinner, do you think you'd get a prize?
No.
Why not?
Because you have a higher chance of getting it. Yeah.
Nice. Great job. You're right. You have a higher chance of it landing on an A because there's 2 more sections that are A than there are B. So the whole purpose of us talking about this problem is so that you understand if you ever are given a spinner with the sections not being the same size, you're going to have to use your pencil to adjust your spinner however you need to in order to make them the same size. For this square spinner, we had to take our spinner and divide it into 8 pieces. However many pieces will just depend on that spinner. It won't always be 8. Okay? So on activity 1.4, we're not going to do the entire activity. I just want to talk about and point out a part of it. On the next page of activity 1.4, at the bottom, yes, please. The probability of an event occurring is a number between 0 and 1. All the fractions that we have done so far have been between 0 and 1. In activity 3, when we did the probability of getting a vowel, that was 0. 0 out of 6. The probability of not getting a vowel was 6 out of 6, or 1 whole. Probabilities are always between 0 and 1. If the event is certain to happen, then the probability is 1. So if it's definitely going to happen, the probability is 1. Like spinning that spinner and getting not vowel. Every single time you spin that spinner, it will not land on a vowel. So that's certain. If an event is impossible to happen, then the probability is 0. Just like that spinner. The probability of spinning a vowel was 0. So that's impossible. Doesn't matter how many times you spin that spinner, it is never going to land on a vowel. If an event is just as likely to happen as not happen, then the probability is 0.5 or 1/2. If the event is just as likely to happen as not, a lot of times we say it's equally likely. Like flipping a coin. It's equally likely that it'll land on heads as it is tails, because there's one head and one tail. Those are equal. Probabilities can be expressed as fractions, decimals, and percents. Just like we mentioned at the very start of rolling, rolling, rolling. Any fraction can be converted into a percent and a decimal. Probabilities can be fractions, decimals, and percents. The number line down below represents the probability from 0 to 1 of an event. So again, it's just another representation, another visual of what probability looks like between 0 and 1. 0 is impossible. 1 is certain. 1/2 is just as likely as unlikely. We also say equally likely. Let's go ahead and write it on here. Equally likely. And here's the new part. If it's between 0 and 1/2, so if it's less than 1/2, we say that that's unlikely. If it's greater than 1/2, but not quite 1 whole, we say that it's likely to happen. On the previous activity when I said, do you think you would win if you spun that square spinner? That's a tongue twister. And you said, no, because it's unlikely, it's less likely to land on a B than it was to land on an A. So these are some vocabulary terms that you need to be able to connect with probability. Less than a half is unlikely. More than a half, it's likely. 0 is impossible. 1 is certain. And equally likely or just as likely as unlikely is a half. So far we've talked about probability on a number cube. We talked about probability on a spinner. In activity 1.5, a simple probability experiment, you're going to be finding the probability of reaching into this bag of marbles and pulling out a marble. Suppose there are 2 blue, 3 green, and 5 yellow marbles in a bag. 1 marble will be drawn from the bag. You go ahead and do number 1 and number 2.